This is very similar to the concept quiz that we took, that we're in theory retaking again early next week if we haven't already done it, depending on the class. So I'm going to take some time with these. Okay, sine of 240 degrees. That happens to be the same location we just were at a moment ago. So if I know that that is the same place as 240 degrees, the sine is just that value there. It's negative root 3 over 2. I saw people circling this, and I don't know if you just are cool with a 50% chance of success. I hope not. But I didn't see any work, and I don't know how you can do the work. It's not comparing this number is definitely bigger than this fraction, of course. That's not what we're asking. We're asking compare the sine values. So the sine of that is the y value. The sine of this is the same value. It's a root 3 over 2, but if it's in the first quadrant, then it's positive. This is not greater than that, so this is false because the arrow should actually be turned the other way. And it's not equal because this is negative and that's positive. Okay, so you look over here, sine of 270. 270 is straight down, and the sine is the y value, so that's a negative 1. I'll give you a hint, unless there's something other than a negative 1 here, this is going to be true because that's the smallest value we can have in the unit circle. But cosine of pi is actually negative 1, so if that has said or equal to 2, then yes, that would be true because they are equal. So therefore, they are not less than. Okay? When we're converting to degrees, there's a couple different ways you can approach that. I would think the better you know the unit circle, the more you're going to be aware of the fact that that's a short triangle, and the short triangle equivalent of that in degrees is 30 degrees. That is the fourth triangle 45-degree angle. So if you subtract 45 degrees from 360, or you just know that the middle triangle there is 315 degrees, then great. But you can also do the multiplication thing. If you take pi over 6 and multiply it by 180 over pi, you are converting from radians to degrees because the radian, the pi is on the bottom. Those cancel. 6 goes into 180 30 times. It's not always that easy, but it is always, can always be done that same way. 180 over pi. Pi's cancel again. 4 happens to go into 180 degrees 45 times, and 45 times 7 is equal to 315. So regardless of how you approach this thing, that's going to work for you every time. Same basic idea here. Now I already spilled the beans. 240 is in fact equal to 4 pi over 3. We know that by the location on the unit circle. But can you also do it based on multiplying? So yeah, you got a 240 times pi over 180. Notice the difference. Here I multiplied by 180 over pi. Here I'm multiplying by pi over 180. I'm turning it into a radian measure, so I want pi to show up. Here I want pi to go away. So pi shows up, the zeros are gone. Now it's a matter of saying, well, what goes into 18 and 24? Well, 6 does. 6 goes into 24 4 times, 6 goes into 18 3 times. So there you go. 45 degrees in radians is pi over 4. And then exact value without a calculator. This is all kind of unit circle stuff. Cosine of a short triangle in the second quadrant, negative root 3 over 2. Sine of a 45-degree angle in the fourth quadrant, negative root 2 over 2. Sine of pi over 2, that's straight up. Since it's up, it's positive, it's 1. Cosine of a tall triangle in the fourth quadrant, that's a positive 1/2 because it's going down the greater distance, but it's going over the short distance. We'll do the rest on the next video.